Hi guys, this video is just introducing the investigation that you're going to be working on for specialist maths this term. So it's all to do with these things called Bezier curves, or I think it's meant to be pronounced Bezier curves, but I just say Bezier. And in particular, we're looking at quadratic Bezier curves, which are actually the simplest kind of those. So what is a Bezier curve, you may be asking? Well, if we just flick over to here, I just did a little bit of a Google image search of Bezier curves in the real world. They're basically curves that can be used for all sorts of things, like for building design. They are often used for roads, so roads often follow sort of a Bezier curve. They might be used in computer graphics. And for all sorts of other applications. They do come up in even in physics as well. Basically, a Bezier curve is a curve from one point to another. And then we have what we call control points, which help define the path of the curve. So I'll show you just a bit of an example of that. So this is a Desmos simulator for Bezier curves, which I just found by Googling. So these 2 points here are the start and end points, and then this one over here is the control point for the Bezier curve, and then this black line is the curve itself. Now that black line I can actually control with this slider here. So here they've called it a value k. If I bring k all the way back to 0, we're at the start of the curve, and then as I increase k, you can see that purple line moves across, but the black line actually traces out the curve. And when the value k gets to 1, we're at the end point. So the curve is actually traced out by changing this value k. Now they've called it k for this simulator, but in the version that you'll be doing, it's just called t. Okay? So we're just tracing out that curve. So let's have a quick squiz at the assignment. So the initial part of the assignment is basically working through some of the mathematics behind Bezier curves. Now that's not part of what you'll submit. It's just to give you an idea of the maths behind it. So we'll try and go through that together in class. If not, I will put some solutions for that initial section up on Daymap for you to have a look at. So that's sort of I guess you can think of that as a formative part. So here's an example of a Bezier curve again so here's the control point, and here are the start and end points of the curve. But the guts of what we're doing is down here. So I have given you the equation for a quadratic Bezier curve. So let's say you're drawing a Bezier curve between 2 points A and C, and this point B is the control point. So this other point S, we'll trace out the curve, and you know how in the simulator we had something called k. In this case it's going to be called t. T is being varied from 0 to 1 in order to trace out the curve. So this is the vector equation here. Now it looks complicated, but it's not too bad. So basically the vector that gets you from the origin to this point S, tracing out the curve, is 1 take t squared, whatever t happens to be, multiplied by OA, plus 2t 1 take t multiplied by OB, plus t squared times OC. So these vectors OA, OB and OC just depend on whatever your 3 control points are, or your start and end point and your control point. So if you graph the position of S and t varies from 0 to 1, then we can trace out the Bezier curve. So what I'll do is I'll show you in a separate video how to do that in a program called GeoGebra, which is what I'm expecting you to use for this assignment, unless you want to use something else, because you do have that option. So what do you actually have to do? Well, you need to be a bit creative for this one. It's not like the maths methods investigation, which is really structured. In this case, you do need to come up with your own idea of where you're going to use a Bezier curve, or at least one Bezier curve, probably at least 2 really. So there's some examples there, like 2 trapeze artists swinging, and their swinging being modelled by Bezier curves. You could look at missiles being launched and one trying to collide with it. You could look at logos and lettering. and graphic design. You could maybe look at roads like we saw when I searched it up, or anything that you want to come up with where you can see an application of Bezier curves. So you may need to do some research on this. So what you need to do is write up the investigation. So you need to give me an outline of what you have chosen to do and the context. You need to tell me a bit about Bezier curves and how they work. You need to tell me how you solved your problem, so how you came up with your design or your solution using Bezier curves. And then you need to show me any calculations, screenshots of graphs and analysis. And you need to talk a bit about reasonableness and limitations. So what were the limitations on your work, and does it seem reasonable? And then a bibliography if you need to as well. So because this is a little bit open-ended, what I'm looking for you to do is show me as much of your knowledge as possible. So if that means going into the mathematical equations behind what you've done, that's great. And it may also involve, like, you obviously need to do some vector graphics with GeoGebra. So you need to show me how that works as well. Okay, I hope that helps you get started, and I'll make a separate video on using GeoGebra. Thanks for watching.